These are exponential equations here. Now, what's nice about 1 and 2 is that they can be done in the same base. Okay, so let's see if we can focus this a little better. Okay, same base would look like this. Okay, we're going to write this guy as a -1. So you can see then that 3n has to equal -1, so we would just set those equal to each other, and we'll get -1/3. It's going to be your final answer. Same with this guy, but what you've got is, I know that 6 to the second power is 36, 6 to the third is 216, but let me just verify that. Yep, 6 to the third. So this means that 6 squared to the -3x equals 6 to the third. So this means that since they are the similar base, I've got -6x has to equal 3, and that would be x equals -1/2. All right, so that's the quick and easy way to solve exponential equations, but they're not all built like this. The reality is that most of the time they don't have a similar base. So what we're going to do is we're going to get this guy down to 10r, 10 to the rth power, as quickly as possible, so that we get 8 times 10r equals 87. Then we're going to divide by 8, so that 10 to the r equals 87 divided by 8. Okay, not a clean number there, but that's okay. Then we're going to take the log. So 87 divided by 8 is that. Then we are not going to be dividing by 8, though. I'm sorry, by 10. That's not how these work. What we need is r to come down so that if the log of 10.878 is 5, divided by the log of 10, okay? Because once we take the log of both sides, the r will come down to the front, and we'll just divide by both. So here we go. Why not do a fraction? Let's do the log of 10.875 divided by the log of 10. Actually, I already know the log of 10. It should be 1. So it's going to be 1.0364. Okay? All right, I'll do this a little bit more step by step here now that I got a little bit of room. 7 times 8 negative 10a equals 37. No, that would be 23. Then I'm going to divide by 7. So 23 over 7. 23 over 7 is 3.2857. All right. Now when I take the log, I can take that 10a down. All right. Now I'm going to divide by -10 and -8 at the same time. I'm sorry, the -10 and log of 8. Oh man, I need some Tums, get some heartburn. All right. So now let's get to a fraction. I've got the log 3.2. You know what? How about all right, try it again. The log of this guy divided by -10 times the log of 8. All right, there's our guy. Negative right there. All right. These are more calculator problems. These guys are, what will the account balance be after 15? What will the account balance be after 20? How long will it take? How long will it take? Okay, so these are two different types of problems here. These guys will require logs. These guys will not. So this one, you just want to set it up. So it looks like the amount of money you're going to have, your account balance is going to be what you started off with. And you're going to compound here, but over here, when you start off with this amount, okay, this says continuously, so you will have e to the 0.05%, doing it for 20 years. I don't know if you can hear that. What is that? That is a wild cart. Okay. I don't know if my mic's going to pick it up, though, because this is a good mic. Now I got 2%, but I'm gonna compound it 3 times a year, so 3 times 15. So this is just the setup for both. Punch it in the calculator, and that's it. So it's gonna take longer to punch in the calculator than it is to set it up. Let's see. Yeah. Oh, man. Ooh, I'm super sleepy. Okay, let's try that again. My guess is that some of us will forget to make that an exponent, and you'll just have the 3 sitting outside. Remember, don't forget to push the exponent there. Okay, where's the syntax? Oh, I got times twice. Okay, so 6,378 right there. This guy, 1 through 3, 5. Man, they cannot get the air right in the classroom. It's like either too muggy or it's too cold. Okay, so 3,628 right there. Okay, so those are just calculator plugins. Just look out. This is compounding. This is compound continuously. This is a little different though. So what we want to do is you can do this one of 2 ways. Whenever they ask how long, you can go ahead and use logs, or you can use the tables. Now I would recommend using logs just because you're cool like that. So you want 8,197. We're going to do this using logs, and we're going to have 1 plus, we got 9% being compounded 6 times a year. And we don't know when it's going to equal, so we're going to cross it out and put 31,000. There we go. Okay. Now here we're going to solve for time, so this is going to be a little different, right? So what I'm going to do is I'm going to first of all divide by the 8197. You'll actually do this every single time. So let's take that 31,303.92. We're going to divide by 8197. Okay, this is the proportion. So what we're looking at here is we want to know, when does this ratio actually equal the 380% growth that we're supposed to see. Okay, so I don't know what 0.09 over 6 is, so let's do that. Okay, so that's going to be 1.0156 to the t. Okay, now what this is really now it's this up here. Okay, it's that situation. We want to take the log of both sides so that the 6t will go in the front or in the back, whatever you'd like to imagine that as, and this will be the log over here. We're taking the log of both sides, and this is going to give you a very accurate solution here. Take that, whatever that is, divide that by the log of 1.015. Got it. So it's 90, and then we're going to divide 90 by 6. It looks like it's 15. So 15 years, this thing will grow by 300 and basically 82%. Okay, because you've looked at the two amounts as ratios of each other, and this is this percentage. When is this going to equal that 382%? Okay. All right, same thing here, except probably a little easier actually. We want to know, when does it equal this guy, and we got a little bit more room here. Going to e to the 0.08, but now we've got t up there. But that's okay. All right, we're going to go ahead and divide the 10,000, 163.06. We're going to divide that by the 33.06. So we're looking for 306%. When will that grow? Okay, and I'm just going to write that down for now, but I am going to use my calculator values here so I can get a nice, accurate number. You saw how nice this was. Okay, that's definitely 15. Okay, but now instead what I'm going to do is I'm going to take the ln of this. Okay, the ln allows me to just put the ln of e, which is actually just 1. So you can actually ignore it, and that's why this guy had his own button. Compound continuously happens so much in nature that whatever kind of, if you get into any kind of science, you're going to use the natural log quite a bit. But we're going to divide by 0.08, and it's 14. So t equals 14 years. All right, almost exactly. All right.